In 5.2, we will be discussing the empirical gas laws. You should think back to honors and maybe look back at your gas law chapter and remind yourself of some of these empirical gas laws. Some examples are Boyle's law and Charles's law. Take a look at the pressure volume data for 1.000 grams of oxygen at 0 degrees C. Notice that pressure is increasing going down and volume is increasing going up. Try to establish a relationship between pressure and volume using this data. Hopefully you've established that pressure and volume are inversely proportional. This means that when one goes up, the other goes down. Using this data and this relationship, we can determine Boyle's law, which is P1 times V1 equals P2 times V2. When graphing an inverse proportion, such as volume and pressure, we get a curved line. We do not get a straight line. This is a good test to determine if something would be inversely or directly proportional if you were given data. However, if we graph the inverse of one of the variables of the data, at that point we will get a straight line because it's kind of like graphing the inverse of an inverse. Try this Boyle's law problem at home. See how you do. If you get stuck, bring it to class tomorrow and ask some questions. Charles's law relates volume and temperature. These are directly proportional. Since they are directly proportional, we can develop Charles's law as Vf over Tf equals Vi over Ti. You can also replace the F's and I's with 1's and 2's. When graphing a direct proportion such as volume and temperature at constant pressure, we can see a nice straight line for each one of these graphs. Try this Charles's law problem. Remember that if pressure doesn't change, we don't need to consider it. STP, standard temperature and pressure. You should remember this from honors class. Standard temperature and pressure are often given instead of giving you the data. We must remember that STP means 0 degrees Celsius and 1 atmosphere. These are exact numbers, so they do not get counted when we're talking about significant figures. I can combine both Boyle's and Charles's laws together to create the combined gas law. P1 times V1 over T1 equals P2 times V2 over T2. Complete this combined gas law problem. Don't forget to convert temperature to Kelvin. So this molar volume of a gas, 1 mole equals 22.4 liters, can be used as a conversion factor. Use the molar volume as a conversion factor in this problem. If you have any questions, please make note of them for tomorrow. That's it for this lesson. Please be sure that you read over section 5.2 in your book and be ready for any possible homework quizzes tomorrow. Have a great evening.